Hello chemists, and today we're going to look at our lab on names and formulas. This is going to be a dry lab, which means you're going to do it on paper. The purpose of this lab is to understand and apply the rules of naming of compounds. We're going to look at ionic compounds, including those with transition metals, covalent compounds, and acids. The experiment is going to reinforce a lot of the techniques that you learned during lecture and just to give you extra practice. So some background, ionic compounds. Ionic compounds are formed from a metal and a nonmetal. The metal loses an electron to become a cation, which is positive, and the nonmetal gains the electron to become negatively charged and called an anion. They combine to form the compounds. Now the naming of the compounds are very simple. You say the name of the metal, you say the name of the nonmetal, but change the ending to IDE. So for example, NaCl is sodium chloride. CaF2, even though there are two fluorines in that molecule, is still known as calcium fluoride. Some other things we're going to see with our ionic compounds is they don't only combine with nonmetals. Sometimes they combine with groups of nonmetals called polyatomic ions. There's a series of ones that you need to know. OH-, which stands for hydroxide, NO2-, which stands for nitrite, NO3-, which stands for nitrate, SO4 2-, that stands for sulfate, CO3 2- that stands for carbonate, and PO4 3- that stands for phosphate. When these combine, you don't change their endings, they just say their name. So NaNO3 would be sodium nitrate. CaCO3 would be calcium carbonate. Transition metals can make things a little tricky because they can have multiple oxidation states and take on different charges. In order to say what the charge is, we use Roman numerals. And you should only really be using Roman numerals 1 through 5. So I, III, IV, and V. If you think you need to go higher, you're wrong. If you think you need a fraction, you're wrong. They don't exist in Roman numerals. So when we talk about them, for example, FeCl2, that's iron taking on a +2 charge. That's going to be iron, Roman numeral 2 in parentheses, chloride. When it's FeCl3, that's iron taking on a +3 charge. So we call it iron, Roman numeral 3 chloride. And when we write the formulas, we'll use those charges to crisscross formula rate like you did in lecture. Okay, so chromium 3+ combined with oxygen, which is 2- charge, makes Cr2O3. And good old copper 1+ and nitrate 1- combine right together perfectly to make copper nitrate, CuNO3. Now, covalent compounds require you to memorize a different list, and I apologize for that. And that's going to be your prefixes. These are the guys that are formed between nonmetals only, so there are no charges to help us figure out the formula. So we need to be extremely specific when we're naming them. The electrons in these compounds are shared. So we use the prefixes to say how many of a certain element. 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, which sounds weird, 8 octa, 9 nona, and 10 deca. You should not in this class need to go any higher than deca. And there's one other thing. When mono is on the first element, you do not write it. So for example, most of us know CO2 is called carbon dioxide, not mono carbon dioxide. And let's say you combine it with nitrogen, N2O5, you get dinitrogen pentoxide. Last but certainly not least, we have our acids. And there are two different types of acids. There are your binary acids, where H+, which is what's released in all acids, that's what acids have in common, they release H+, so they'll always start with an H+, is combined with just an element. When that's the case, I like to call those the hydroblankic acids. You just use the root name of the other element. So HCl is hydrochloric acid. HF would be hydrofluoric acid. Then we have what I call the oxyacids, and these are when that same H is this time bonded to one of your polyatomics. And when it's bonded to one of your polyatomics, it depends on the ending of the polyatomic ion. If the polyatomic ion would have ended in 8, then the acid would end in ic. They always used to say 8 something icky. So for example, H2SO4, that comes from sulfate, that's sulfuric acid. When it ends in ite, it would go to OUS. An example of that would be HNO2, since that comes from nitrite, that would be called nitrous acid.